In this video, we're going to be talking about writing equations in vertex form. So what we have been graphing with, so here are my three types. We have standard form, ax squared plus bx plus c. We have our vertex form with our hk that gives us our spot where our u is going to happen, and our factored form, so when we factored it and solved. So we've worked with standard form using quadratic formula, and we've worked with factored form when we factored it and did ZPP. Now we're going to work with vertex form and graphing it. Okay, so here are my steps to write it in vertex form, and then we're going to use completing the squares, our second method of learning. Okay, so this is called the axis of symmetry. Okay, so when we are using this, we are finding the axis of symmetry that we're going to mirror our u off of. So first we do x equals negative b over 2a. That's going to give me my h value in my vertex. Okay, that'll give me x equals, which is my h. And then to find my k value or my y value, we plug it in and solve it, and that will get my k value, and then we will write the vertex. Okay, so first I find my a, b, c. So a is 1, b is negative 10, c is 16. My first step, x equals, when I plug in negative b in for my, because it's negative b over 2a, it becomes a positive 10 over 2 times a. So 10, 2 times 1 gets me 2. 10 divided by 2 gets me 5. So this represents my h value in my vertex form. Now we plug it into my equation to find my y. Okay, so I got y equals, I take out all my x's and plop in my 5. And if I type that whole thing into my calculator, I get negative 9. And that represents my k value. So my last step is to write out my vertex equation. If there's a number sitting in front of x squared, it will need to sit right there, but since it's a 1, we could just put a 1. Remember, when we put our h value in, we always flip it, so it becomes a minus 5, and my k value stays normal. So my u would start at 5, negative 9, because you're finding a vertex and then plopping it in. Okay, my next one, a is 1, b is 3, c is negative 10. So my first step, x equals negative b over 2 times a. It's like taking the average of your a and b. So I get negative 1.5. To find out the y, so that was my h. Now I got to find my k, so I plug it in. So negative 1.5 squared plus 3 times negative 1.5 minus 10. If I type that whole thing into my calculator, I get negative 12.25, and I can write my equation. There's a 1 that sits in front of there, so I'll put a 1 right here. X, flip my x value, keep my y value normal, because that represents my k. My k always stays normal, my h always flips. Okay, my next one, a is 1, b is negative 4, and c is negative 2. So x equals negative b, negative 4 becomes positive. 2 times 1, so 4 divided by 2 gets me 2. That represents my h. Remember, when I take a letter out and put in numbers, I'm going to use parentheses so my negatives don't get messed up. When I type that full thing into my calculator, I get negative 6, which represents my k. So y equals, we got a 1 in front of here, so 1 times x minus 2 squared minus 6. Okay, my next one, a is negative 4, b is 4, c is 8. What's nice about this is you don't pull out a GCF and you don't have to factor it all. So x equals negative b over 2 times a, which gets me negative 4 over negative 8, so 1/2. So there's my h. We plug it in to find the k. So negative 4 parentheses squared plus 4 times 1/2 plus 8. So when I type that all in, I get 9, which represents my k value. So my last step, I got y equals, there's a negative 4 there, so negative 4 x minus 1/2 squared plus 9. Okay, and now by completing the square method. So to complete the square, remember we got to find that new c value. So we're going to move this other c value over. We're going to keep that y there. My b is negative 8, so I do my b divided by 2 squared. So negative 8 divided by 2 squared, negative 4 squared, which gets me 16. So 16 is what I add to both sides. So negative 6 plus 16 gets me 10. This is my shortcut, so x minus 4 squared. Okay, my vertex form, it stays squared. So we're not really solving, we're just going to get y by itself now. So I found that perfect square, now we're just going to get my y by itself. So y equals x minus 4 squared minus 10. There's my vertex form. Okay, my next one here, we got to get the 8 over. Okay, problem is, the thing that sucks about completing the square is when there's a number in front of x squared. So we need to take that out. So it now sits in front, this x squared plus 4x, it flips all the signs, but I need to move them over. So to move them over, I divide the entire other side by that negative 1. So I got a negative y minus 8 equals x squared plus 4x. Now I can do my completing the square part. So my b is 4, so 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4. So I add 4 to both sides. So negative y minus 4 equals x, it's this number, so plus 2 squared. And then we solve for y to get my y equals equation. Okay, we're not trying to find the x-intercepts. That's not why I'm square rooting and subtracting 2. I'm just trying to find my equation of my line. So I add 4. So I got negative y equals x plus 2 squared plus 4. Just attaches onto the back end. And I divide everything by negative 1. So it just becomes a negative x plus 2 squared and a minus 4. Make sure what you do to one side, you do to the entire other side. Okay, my next one here, we're going to get that 6 over. So y plus 6 equals x squared plus 3x. Don't have any GCS, so 3 divided by 2 squared, so 1.5 squared. Gets me 2.25, so that's what I add to that 6. So y plus 8.25 is equal to x plus 1.5 squared, and then we just move them over. So subtract 8.25, subtract 8.25. So y equals x plus 1.5 squared minus 8.25. Okay, my next one's going to have a GCF. So first we move the 9 over. They're always a lot harder when you have to take a GCF out because then everything gets a lot uglier. So I got y minus 9 equals, it sits in front until I move it over, and then I move it over. Okay, so I divide everything on my other side by 5. So this decimal here is 1.8. And now I can work it. So I got negative b divided by 2 squared, so negative 1 squared, so 1 is what I am adding. So y over 5 minus 0.8 equals x minus 1 squared. And now we got to solve for y. So I got to add that 0.8. So y over 5 equals x minus 1 squared plus 0.8. And now we got to multiply the entire thing by 5. So everything by 5. So it's gone on my left side. It just sticks into the front of my parentheses. Don't distribute it because that squared tells me there's technically 2 of those sets of parentheses. So we can't distribute into them. And then 0.8 times 5 will get me 4. Okay, we're going to bring that 11 over. Get that negative 4 out, so he's going to chill in the front for now. Get him over to the other side. So make sure what you do to one side, you do to the entire other side. So y over negative 4 minus 11 divided by 4, 2.75. So negative b divided by 2 squared, b divided by 2 squared, so negative 2 squared. So 4 is what I am adding to him. So y over negative 4 plus 1.25 is equal to x minus 2 squared. We get that 1.25 over. Multiply everything by negative 4. So y equals, it's gone on the left side, so negative 4 x minus 2 squared plus 5, because two negatives make a positive. So completing the square is a lot faster when you don't have a GCF to take out. If you have a GCF to take out, I would do the axis of symmetry way, unless I specifically make you do this. Okay, so we subtract 5. Take that 3 out. Divide by that 3 on everything on the other side. So y divided by 3 minus 2.33 is equal to x squared minus 4x. B divided by 2 squared, so negative 2 squared, which gets me 4. Actually, this is 1.67. 1.67. When I add 4, I get 2.33. Squared minus 7. Okay, when does this method, why does this method of completing the square work better? You don't have to factor. The reason it would be worse was when you have a GCF that you have to take out and move over. Okay, show that they are equivalent. Okay, so you got different methods, so you're trying to get to vertex form. So let's say we choose this direction here. I could use my first method that I talked about today. So x equals negative b over 2a. So x equals a is negative 2, b is negative 20, and c is negative 57. So x equals negative b in for a negative 20, 20 over 2 times a. So 20 over negative 4. So my x equals negative 5. Step 2, we plug them in. Okay, if we were to simplify this, we would get negative 7. My last step, we put it into our equation. So y equals, the a on it's negative 2. X, we flip the sign when we put it in, and my other one stays normal. And that is the equivalent. Okay, you could have also done completing the square to get to it. It would take a little bit longer because there would be a GCF of negative 2 that you'd have to take out and move over and then bring back. Okay, let's say we want to go for this one to this way here. So that squared means there's 2 of them. So I write them out twice. And then I either FOIL, distribute, or box. I leave this 3 out here until my end. So x times x gets me x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. Negative 4 times negative 4 is 16. I still got that plus 1 sitting on the outside, and now I can well, let's simplify in my parentheses. So I get minus 8x plus 16 plus 1. Now my step, I can distribute it in. But I want to simplify those parentheses before I distribute the 3 so I don't mess it up. So I got 3x squared minus 24x. 16 times 3 plus 48 plus 1. So 3x squared minus 24x plus 49, which is my answer. Okay, you could have also done left side to right side, in which case you would have either had to factor it, completed the square to find vertex form. Okay, so y equals negative 2x squared plus 16x minus 29. So first we need our vertex and our vertex form here. So I'm going to do my first method because it's easier. So my a is negative 2, my b is 16, and my c is negative 29. So x equals negative 16 over 2 times a, negative 16 over negative 4. Okay, so there's the x value to my vertex. Now to find the y value to them, we plug them in. So negative 2 times 4 squared plus 16 times 4 minus 29. Okay, we're going to get 3. So there's the 3 for my vertex. So that's where my u will start. So if I go over here, right 4 up 3, my u should start. It's going to be a sad face because it's got a negative out front. Okay, writing the equation then, so my step 3, I got y equals, there's a negative 2, so negative 2x, we flip our h value of 4 squared, and then keep our k value normal, so plus 3. So there's the equation in vertex form. I can go ahead and do my description here, so I know it's going to flip or reflect or open down. It is going to go right 4, and it is going to go up 3, and that 2 in front is going to make it stretch. Okay, to find the x-intercepts, you could either use factoring, you could use quadratic formula, you could complete the square if you wanted to set it equal to 0. So it's kind of up to you on which way that you want to do it. I'm going to use quadratic formula because it's going to be the fastest. So I've got x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I'm going to simplify underneath my square root first to see what I get. So I got x equals negative 16 plus or minus the square root of 2 times negative 2 in the bottom will get me negative 4. So I'm really just typing in anything underneath the square root, not with the square root. So 16 times 16 is 256. And then 4 times 2 times 29, we get a negative 232. Oops. So 256 minus 232, we got a 24 underneath there. Okay, I would type this into my calculator, one with the plus sign, one with the minus sign, and then find the decimal value. Okay, the decimal value you get by pressing this button above your double enter sign. On the test, it won't be a decimal, it won't be this ugly, but that will tell you where it's crossing your x-axis. So it's a little more than 2. So first off, that's my x-intercept. Okay, so it's a little more than 2, the decimal, and then it is a little more than 5. We got that part of our u. Now we got to find our y-intercept. To figure out where it crosses my y-axis, your x will always be 0. So we actually just plug in, I'm going to erase this so I have some space, we plug in 0 for our x to find it. So y equals negative 2 times 0 squared plus 16 times 0 minus 29, or it's always that back end number. So it's crossing at negative 29, which is way down here, so I don't even really need to graph it. So there is my shape. Left to right, we got all real numbers. The lowest it goes is negative infinity, and it tops out at 3 with a closed dot. Okay, my next one here, step 1, we got a is 2, b is negative 2, c is negative 12. So x equals negative b, that changes to positive. 2 times my a, so 2 over 4, so 1/2. So that's my x value. We plug it in to find our y. And I get negative 12.5. Okay, writing the equation then, so step 3, I got y equals, I got a 2 in front, so 2, x, we flip our 1/2 and keep my next one normal. So that's my equation. Okay, so then I graph him, so I go right 1/2 down 12 1/2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I go right 1/2 down 12 1/2. There's my point. Okay, y-intercept is going to be the faster one here because all I do is plug in 0 for x. Because anytime I'm on the y-axis, or the y-axis, the x value is always 0. So it's going to be -12 right there. And then quadratic formula, or you could factor for this one. So let's say we factor instead of using quadratic formula for this. Okay, you set it equal to 0 because that's what all your y values would be. And then we're going to factor. So it looks like they have a GCF of 2 that we got to take out. So 0 equals 2, x squared minus x minus 6. We're going to move them over to the other side so that my right side is normal. So I divide. 0 divided by 2 gets me 0. And then I'm going to factor normally. So multiplies the -6, adds to -1 is going to be -3 and 2. And then I do my ZPP. So x minus 3 equals 0, x plus 2 equals 0. I add 3 and get 3. I subtract 2 and get -2. So my x-intercepts are going to be 3 and -2. So it crosses my x-axis at 3, -2. And then we're going to build that U. Okay, so domain left to right, I'm good with all real numbers. The lowest it goes is -12.5. And then it keeps going to infinity. So if I look at my vertex equation, I can figure out what my stretching, compressing, and all that is. I erased it. It did have a 2 in the front, so it's going to stretch. It will go right 1/2. Good. And then it will go down 12 1/2 based on the equation that I had written before.